Okay, so predicting whether or not a reaction can happen for double displacement reactions. Now, again, as you should know, this is double displacement reactions because they are both compounds and you don't have any individual free elements here. But anyway, in order to do this, in order to tell whether or not this is going to happen, we got to define what we mean by happen. When I say happen, I mean the two reactants have to produce a product that is not aqueous, that is not dissolved in water. If all of the products are dissolved in water, also known as aqueous, that means we're going to say the reaction didn't happen. However, if one or more of the products is not aqueous, which means liquid, solid, or gas, or otherwise unable to dissolve in water, we'll say the reaction happened. Here, let's go through an example. I'll show you what I mean of how to do this. And we're going to start with this first one here. In order to figure out where this reaction is going to happen, unlike with the single displacement ones, for these you do need to predict the products. Okay, so that means I'm going to switch the pieces first. So I'm going to, let's see, I'm going to put silver here and then sodium here. So I have sodium nitrate plus silver sulfate. I guess I might as well balance one sodium, one sulfate, one nitrate, two silver, okay? But that's a little beside the point, because here I just want to find out whether or not it's even going to happen. I need to use the solubility table, which looks like this, to determine for each of these substances whether it is able to dissolve in water or not. If it can dissolve in water, I'm going to put aqueous next to it, the little AQ in parentheses. If it is not able to dissolve in water, I'm going to put S for solid. Occasionally you may see like something, if you ever get oxygen or hydrogen like O2 or H2, that would be a gas, got to use some common sense. Or if you get H2O, again, use some common sense, that's liquid. But at any rate, let's practice with this, okay? So in order to figure out what it is, let's look at silver nitrate. You're going to use this chart, and most of the time you look it up by finding the anions. So look at nitrates, look at sulfates, nitrates and sulfates again, and be able to tell whether or not it can dissolve in water. The two vocabulary words is soluble, meaning yes, it can dissolve in water, or insoluble, meaning no, it cannot. An example of soluble, it would be like table salt. That'll dissolve in water, or sugar. That would dissolve in water, I suppose. So that's a slightly different matter, but it gets the idea, like able to dissolve in water. Insoluble, cannot dissolve in water. An example being sand, where you can put some sand and some water together and mix them all day and all night, and it just will not dissolve. That would be an insoluble compound. So, if it turns out that something's soluble, we'll write AQ. If it turns out that it is insoluble, we will write S. So, let's see. Silver nitrate. You got to look up the anions on this list. There's nitrate right there. Now, I'm zooming that in just a little bit for the sake of making it just a little bit clearer to see. Okay. So, if you want to find out where this is soluble, we find the nitrate. And nitrate is in this column that says ions that form soluble compounds. In other words, it says nitrate compounds are soluble. And are there any exceptions? No. In other words, all nitrates are soluble with no exceptions. So I'm going to put AQ here, and I'm going to put it over by this nitrate also. They're all soluble. Okay, this is leading me toward figuring out whether or not this reaction can happen. Next, sulfate. The other two are sulfate salts. Okay, let's find sulfate on here. Sulfate, sulfate, sulfate. Oh, there it is. Okay, now the sulfates, according to this, zoom this in even more so you can see it. The rules for sulfate are sulfates will dissolve in water because they're in the soluble thing, and they will dissolve unless they're paired with one of these things. Okay. Well, let's see. Sodium sulfate. Sodium sulfate is not one of the exceptions. Therefore, we'll say it follows the rule of being soluble. So sodium sulfate will be labeled as aqueous. Next one, silver sulfate. Okay, let's look at silver sulfate. Sulfates will dissolve in water because they're soluble unless they're paired with things that include silver. So sulfates will dissolve in water unless they contain silver. Well, that's this one. So since it won't dissolve in water, we're going to put S for solid because it'll just clump up at the bottom of your container eventually. And, alright, looking back at the overall view of our equation, of our chemical equation right there, yeah, there it is. Aqueous, 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 solid. We have a product that is not aqueous. In other words, that cannot dissolve in water. So because one of the products is not AQ, we're going to say, yes, the reaction happened. Yes, the reaction happened because one of the products is not aqueous. Because one of the products is not aqueous. Write it down for emphasis. Alright, that's how you know. So, let's look at the next one and practice likewise. Okay, and feel free to pause anytime and work ahead and then wait for me to catch up in the video to see if you're correct. So, let me work this out. Let's see, sodium with chlorine, copper with phosphate. Now let's see, copper's got a +2, phosphate's got a -3, so it's got a +2 and phosphate's got a -3. So that would be the formula. And then I suppose one could go and balance this out with, let's see, 3 coppers and let's see, that leaves 6 chlorine. Coppers, that makes 6 chlorine. So you'd have to have 6. So you'd have to have 2 of these. And, okay, well, that's properly balanced. But at any rate, that's actually a side thing, though, because in order to figure out what's going to happen, it doesn't matter how it's balanced, though you will have to do this on the test. As far as just the task of figuring out whether it's going to happen or not, the balancing isn't as important to figuring out whether it's aqueous or not, for example. So let's look at the first one, sodium phosphate, and find phosphates on this chart. And looking at it, I see phosphates over here. Now, sodium phosphate, what's it going to be? Phosphate is here under the insoluble compounds. Phosphates will not dissolve in water unless, and here's the exceptions, so phosphates will not dissolve in water unless they're with group 1 ions or ammonium. So unless they're with group 1 ions or ammonium, well, what the heck's a group 1 ion? Group 1 ions are all of the things in group 1 of the periodic table. That's all of these things, including, might I add, sodium. So, basically what this table is telling me is that since phosphates won't dissolve in water unless they're with a group 1 or ammonium, and then we look at this thing, that's a phosphate with a group 1. Therefore, it dissolves in water, therefore it is AQ. Let's look at the other phosphate while we're at it. What about copper 2 phosphate? Well, copper 2 phosphate, again, phosphates don't dissolve in water unless it's a group 1 or an ammonium. Well, copper is neither of these, therefore it follows the rule of not dissolving in water, therefore this is a solid. I can already say the reaction is going to happen, but for completeness' sake, let's look at the others. Copper chloride. Where do you find this on the list? Again, look at the anion. At the anion, I see right here, it's under halides. Alright, so looking at the halides, there you go, now it's in view. It says halides are soluble unless it's paired with one of these three. Okay, so copper paired with chlorine. Well, copper isn't one of the exceptions, therefore we follow the rule of halides are soluble. That's AQ there for the copper chloride, and or rather copper 2 chloride. But at any rate, let's look at the sodium chloride. Well, aside from probably life experience, how do you know it's soluble in water? Look it up on the chart again. Okay, so there's chlorine, and chlorides are soluble unless they're with one of these, and sodium isn't one of the exceptions, so therefore it is soluble, and we put AQ. Again, yes, reaction happens because one of the products is not aqueous. Alright. So we continue onward. Let's see, get this into position and make sure it's properly focused. Alright, so go ahead and work ahead on this one. I'm going to work these out. You can pause the video and see if your answers match with what they should. Okay, so let's see, sodium and nitrate. And of course, feel free to watch as I work these out in case that's something you would like help with also. The carbonate is going to come over, the sodium goes with the nitrate, the ammonium comes with the carbonate. So NH4, 2 ammoniums with 1 carbonate, because carbonate's a 2- and ammonium's a 1+. I could balance this out. Honestly, it wouldn't make too much of a difference. Might as well for completeness' sake. 2 sodiums, 2 nitrates, 2 nitrates, 2 ammoniums, 1 carbonate. There we go. Looking these up on the table. Sodium carbonate. And let's see, sodium carbonate and ammonium carbonate. Okay, let's look up carbonate. So sodium carbonate and ammonium carbonate. So carbonates will not dissolve unless they're paired with group 1, well that includes sodium, or ammonium. So in other words, both sodium carbonate and ammonium carbonate will dissolve in water. So for sodium carbonate, I put AQ, and for ammonium carbonate, I'm going to put AQ. Next, nitrates. I got sodium nitrate and ammonium nitrate. So I go and look at nitrates on the chart and find them right here. Always soluble, no exceptions. So that means so making sure this is in view for you. Ammonium nitrate, aqueous. So sodium nitrate, aqueous. Aqueous. All products are aqueous. Therefore, we're going to say that this reaction does not occur. And it doesn't occur because all products are aqueous. So let's see, bringing the whole thing back into view. And I'm going to just say no reaction. Alright. Let's look at the next one. Calcium chlorate, potassium chloride. KCl plus Ca, and then 2 chlorates, because chlorate's a -1 and calcium's a +2. And then, let's see, that's the correct formula, so let's see, 2 chlorates, 2 potassiums, 2 chlorines, 1 calcium. Okay, correctly balanced. Okay, let's look at the halides, because that's what involves chlorine. Alright, it will dissolve unless it's with silver, lead, or mercury. And these chlorides are neither with lead, nor silver, nor mercury. Therefore, they're both aqueous. potassium chlorate and calcium chlorate. We got to look those up. So looking them up on the chart, the chlorates are right here on this chart. It says that they are soluble with no exceptions. And since they're soluble with no exceptions, I can put aqueous for both of them, thus telling me that once again, I've got a reaction where all products are dissolved in water, and we're therefore going to say no reaction. Simply because no non-aqueous products are made. All products are aqueous. Okay, next. How do you handle this one? What you do, same as always, switch your parts. For part 1, put the calcium here, put the hydrogen here. So it's calcium nitrate, and calcium is a 2+, therefore it's going to pair with 2 nitrates. Hydrogen plus hydroxide is water. Okay, well, suppose we can balance that out. Couldn't hurt. 2. Oops, I put that in the wrong place. I meant to put the 2 here. And then let's make sure. So 2 nitrates, 1 calcium, 1 calcium. 2 hydrogens plus 2 more is 4 hydrogens. That means I need a 2 here. That's 4 hydrogens. And then 2 oxygen, 2 oxygen. Okay, whatever. Nitrates. Going back to here, we look at nitrates and see that all nitrates are soluble, no exceptions. So I'm going to say aqueous and aqueous. And then what about the calcium hydroxide? I look at hydroxides. Will it dissolve in water? The answer is no. Hydroxide will not dissolve in water unless it's with calcium. Alright, that means this dissolves in water. It's the exception. Like most hydroxides will dissolve in water. Okay, there's no hydroxide here. This is water. Okay. Oh, see where that wasn't in view. Here we go. There's no hydroxide here. This is water. Okay, guys, this is where common sense comes in. At regular room temperature, water is a liquid. It's not going to appear on the chart. Okay? I see a non-aqueous product. Yes, there's a reaction because one of the products is not aqueous. Okay, next one. Aluminum and ammonium trade places. Ammonium chloride plus aluminum phosphate. This is the correct formula. +1 and a -1. This is the correct formula because that's a +3 and that's a -3. Okay. I suppose for balancing's sake, 3 ammoniums. I need 3 ammoniums there. Just have 3 chlorines, 1 aluminum, 1 phosphate. Done. But working this up. Okay, halides will dissolve unless they're with silver, lead, or mercury. So these are both halides, and these are neither lead nor silver nor mercury, so they both dissolve according to the chart. Phosphates. Ammonium phosphate and aluminum phosphate. Let's see what the chart says. So that is ammonium phosphate and, let's see, what was that again? Aluminum phosphate. Phosphates will not dissolve in water unless they're with group 1 or ammonium. That's ammonium, so this phosphate will dissolve in water according to the chart. This is neither group 1 nor is it ammonium, therefore it will not dissolve in water, and we put S. Non-aqueous product means yes, reaction. Okay, that's the overall one for aluminum and for aluminum chloride and ammonium phosphate. Now let's see this next one. Iron 2 bromide and magnesium chromate. Alright, switch the pieces, put the iron here, put the magnesium here. MgBr2, correct formula, and FeCrO4. We'll assume the iron retains its -2 charge. And this is it's positive 2 charge. This is the negative 2, so 1 of each. No balancing necessary. Great. Well, what's their state? What's their physical state? Bromine, where am I going to find that? Well, that will be found on this chart under the halides. So, being the halides, computer. Being that it's under the halides, bromine right here is going to follow the same rules as all those chloride things we did earlier. It will dissolve unless it's paired with silver, lead, or mercury. Alright, so bromine will dissolve. Bromine compounds will dissolve unless it's with silver, lead, or mercury. That's neither silver, lead, nor mercury, and neither is that. Oops, you can't see that. Okay, so compounds with bromine will dissolve unless it's one of the exceptions, and this is not one of the exceptions, so we're going to say aqueous for both of you. Now for chromates, magnesium chromate and iron chromate. Looking at the list for chromates, let's see, chromates, here we go. Chromates will not dissolve in water. They're insoluble unless they're with group 1, calcium, or magnesium, or ammonium. Alright, well, looking at this chromate is with magnesium. So this chromate is an exception to the chromates don't dissolve rule. So because it's an exception to the chromates don't dissolve rule, it dissolves, and therefore we put AQ. Iron is not one of the exceptions. It's not group 1, it's not calcium, it's not magnesium, and it's not ammonium. So iron chromate will not dissolve. Solid product. Oh, whoops, you couldn't see that. So there we go. Let's get that in proper view. So iron chromate is not one of the exceptions. It is a solid. So since one of the products is non-aqueous, we're going to say yes, reaction. Oops, other way. That brings us almost to the end. And scoot these down maybe so that more things are in view for you. Okay, magnesium sulfate, barium hydroxide. So for magnesium sulfate and barium hydroxide, once again we go to the chart. And well, hold on a sec. Let's actually figure these out first. So magnesium is going to come over here and join hydroxide. So MgOH2 plus barium is going to come join sulfate. So barium sulfate. Sulfate's a 2 minus, barium's a 2 plus. Stays as it is. But anyway, let's consult the chart for sulfates first. Sulfates will dissolve because they're soluble unless they're with one of the exceptions. Magnesium is not one of the exceptions, so yes, this sulfate will dissolve. AQ. How about this sulfate? Barium. Oh, look at that. Barium is one of the exceptions. Barium sulfate will not dissolve in water. So because barium sulfate will not dissolve in water, let's get this up into view here. I'm going to put S here, so I already know the reaction is going to happen, but let's finish this for completeness' sake. Let's look at the hydroxides. We have barium and magnesium hydroxide. Looking at the hydroxides list, hydroxides don't want to dissolve in water unless they're with group 1, calcium, barium, strontium, or ammonium. Oh look, barium right there. Ah, there you are. There's barium. And according to the rules you can see up here, hydroxides don't usually dissolve unless they're with barium, so this one dissolves. AQ. Let's look at this hydroxide. Magnesium hydroxide. Hydroxides won't dissolve unless it's with one of these. Well, none of these are magnesium. Therefore, this is not an exception, which means it follows the hydroxides don't dissolve rule. Solid. So, looking at the overview of that problem, what you have is both products are solid. Therefore, yes, reaction, because anytime you have one or more non-aqueous products, you say that yes, you had a chemical reaction. Alright, there's an overview of how you predict reactions for double displacement chemical reactions. Happy studies!